So this is the next step in this tutorial, where so far we have something like a spaceship with physics, like a collision shape or physics shape connected to it, so it can, like, in a sense, the spaceship has like a shield of physics, so it can knock stuff over, and it can shoot these sort of bullets that also have physics and sort of like work like projectiles. And then last, that I have added something like a laser that somehow also somehow has this effect. And the idea is to create something like a sci-fi. You can, like, see that it sort of it pushes stuff. So something like a sci-fi laser, and perhaps it's a bit easier to, like, see what it does here. That it sort of pushes stuff over and then keeps pushing it. So how do you create this something like laser grav gun thingy, and like go over here, and you can, like, get an idea of, like, it sort of pushes stuff away, sort of like a gust of wind, or like something like a Jedi force powers almost, but it's just supposed to be something like almost like it hits stuff with something like you could say projectiles, or something like a nasty laser that somehow tears into stuff, right? So how to build this? And to start with, you can see that it's been attached to something like the camera here. And to get that to work, when you press play, notice that there's something called, where is it, the camera, near plane. The near plane. And that's something like at a certain distance, it doesn't render stuff. So for instance, if I set this to 4 and I press play, you'll notice, no, let's see how they set it to 10, I think. And you'll notice that that it starts not to render as were the objects, only some of the objects that are, like, in front of the screen, and that's because the near plane is something like a plane right in front of the camera, where it sort of like stops drawing stuff. So you want that to basically be as close to the lens as you can get, or you'll something like start cutting the something like guns to bits. So in a sense, it looks weird. To avoid that, you just need to, like, set the near plane to, like, almost 0, so that the camera doesn't cut stuff away that's perhaps like 5, 10, 15, 20, or 20 centimeters in front of the lens, where it can look like it's all like cutting the, in a sense, the geometry away instead of rendering it. It's because of this here. So what I have done to make this work is that this is sort of like a rather simple script, where this is basically the script. Needs to click here, laser, and here, show the content over here. So I just basically click the object that I know that the script is attached to, and then it's sort of like added script. It's connected here. You can see laser doom ripper script. I have written that myself. It's not part of the engine. And then I just click show in the content window, and I can, like, find it here. So this is the script. So let's just quickly go over what it does. It takes the position of the let's see, laser doom river. Let's see here. So what it does is that first I get the position of let's see if I can explain it. Here is sort of like the direction that I want to shoot. Notice that this is the barrel. You can say this is the metal of the gun, and then here is the barrel, right? And what I do is that I basically get the position of both of those, and then I subtract them. So first move this in here, and also here. So let's see if I got this right. Laser doom number 0, laser doom number 0. So the order is, like, different here. Let's see, have I really gotten that right? Laser. Yeah, it looks that way. So, and then I get the position of those. You just move this out here and you search for position. And there's actor get position, not local position but global position, like in the world of you say the 3D world. and then I get these, and I basically just control D or duplicate that, and now I have the position, and then I subtract those. Let's see here, and let's see, why did I let's see, and then I subtract those, and there's something here, I subtract those to basically get, as it were, the direction here. So if I'm not mistaken, I basically let's see, here and here. So notice that this here is a little bit in front, and this here, the second that I subtract, is a little bit here. So we get, in a sense, from here, and we subtract this, so we basically get the vector basically from you say from here to here, the blue arrow. So we get that vector sort of shooting forward. And then when we want to use a raycast to something like detect, you find a raycast by searching for raycast, and let's see if I can remember where it is. Where was it? I think it's physics. I got it here under physics. Let's see if I can get it here, right here. So static bool FLAX physics. You can see the static bool FLAX engine dot physics dot raycast, and it's I find it by searching here and then scrolling to physics, and notice that there's like 2 boxes here. Let's see here. So we just search for raycast again, and there's some different ones. And from what I know, did I get the same here? Raycast here, but I got the one you see here. This one here has hit info, and this one here doesn't. So you want the one that, in a sense, gives you the box that tells you the hit info, and you can see that it's the one that I got here, because then I can unpack that and get the name, for instance, the type of the collider, and also the distance that the raycast is hitting. And a raycast is basically a laser that is shot into the world, and then it just sort of like tells you what it hits. It's not this red laser here. That's some graphics and some, in a sense, a mesh that I created in Blender or 3D program. Suppose that I have like a raycast here in the middle of the screen. It had hit the wall here, and for instance, when I have this sort of like raycast hit, if I, for instance, have a raycast that just shoots directly in front of me where the mouse is now, the collider will tell me that I'm hitting something like the walls and the collision shapes, or the collision physics on the walls. If it is moved here and it hit here, it would say that I was hitting these boxes, and then it will like go back to here, and the raycast in this collider will tell me now I'm hitting the walls. So it tells me, as it were, a laser that shoots forward directly in a direction and tells me what I'm hitting. And that direction is what you input here, and I get that direction as like constantly being, in a sense, let's see here, this point subtracted from this point, or something like the laser that's basically this blue arrow here. So that's basically shooting forward directly from, as it were, the laser gun. So that's how you sort of like put all this together. And then this direction here, it needs a vector that is some total 1 meter long, or has like the units of like 1 quotation marks. The length has to be 1, and that's quite difficult to calculate. But FLAX has a function called normalize that does that, and I think you get an error if you don't do this. So you search for normalize, and you just sort of like scroll down until it says math, and then normalize, and then you get this. And if you don't do this, FLAX engine, I think, needs this to have some total length also of like 1. And for instance here, the distance between these 2 points isn't 1 in the video game world. So you have to like correct that, and you use the normalize to do that, and then you can connect it to the direction and say that the raycast, when you press play, basically let's just click no here, shoots forward directly from the laser. So when I press in a sense shift, or right mouse button, it shoots this red laser that shoots directly from that sort of like from the laser cannon, and then hits something and then does stuff to that, and in this case something like adds physics simulations. So that's sort of like how you do that, and you need this something like raycast box, and then you'll notice that it says there's one that just says return yes or no, has it hit something, or boolean, but you want the one that says hit info, and then you want to move that out, and then you search for unpack. So you find a raycast hit, unpack raycast hit, and then you get all this. You can, for instance, get the name of the collider, what you're hitting, the material, or the name of, as it were, the material, or in a sense the textures, the normal direction, the distance to what you are hitting, the point 3D of, in a sense, the for instance, let's see here, if you hit the, let's see here, the point here, this will have like, for instance, a position in 3D space. If you hit like a point here, that will have a position in 3D space, and you can get that information from the raycast. So it's basically shooting a laser into the level that tells you a bunch of stuff. And raycasts are very, very useful, and you want to like learn how to like use them if you want to make video games. And it's as simple as getting that box. And I search for raycast on the physics, and notice that that this one here says static bool FLAX engine physics raycast, and then it says vector 3 origin, vector 3 direction, max distance equal blah 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 blah, bool, and then unit max value bool hit triggers true. And then the other one says, let's see here, performs a raycast against the last sentence, performs a raycast against objects in the scene, returns results in a raycast hit structure. We want that, because if we get this, there won't be a raycast hit structure. So you want to search for the one that says physics, and then this one performs a raycast against objects in the scene. This one performs a raycast against objects in the scene, but also returns a raycast hit structure, or something like, you can see that this here is what we want and not this box. So that's sort of like how you find that. So notice now that we have the collider, and that's sort of like really, really nice. It's what's called a physics collider. So if we move this out, there's something here called physics collider actor. And you will see that this has like some functions or some stuff we can do once we have that. And this is something like that list. And there's something called get attached rigid body. And once we have that, we can start applying forces and velocity to whatever we hit. Because we can then tell the engine that rigid body, we want something like more gravity, or we want more forces on it, or we want to add to its velocity. And that's basically what I've done down here. So this is like a bit difficult to read, but I basically let's see here, physics collider, get attached rigid body, you can see that's here. And then because it was like I wanted, and then I want to something like set the velocity. And what I do is that you can like, if you want to set the, if once you have a rigid body, you can search for rigid body. And then you can like see all the kind of like stuff. You can add force, you can add torque, you can do all kinds of stuff. You can add angular velocity, so you started spinning and so on, and blah blah blah. And you can get, and you can like set stuff. The one that I use that works is set linear velocity. And then basically I just connected this and said that I wanted, let's see here, I want you know, the direction, you know, the direction. Notice here, this is the direction forward, where we talked about something like these 2 points, and then creating this something like blue vector here, this vector here. I want to add a force that's basically this, or this blue arrow first. So this is, you can see that here I basically input that as the direction or the value that I want to apply this velocity changes. So I add velocity to whatever I hit in a certain direction and start pushing it away by increasing like how the speed, the linear speed of it, you can say. And then because when I did that it almost didn't move, I just had to like take this number here and multiply it by 100, And when I do that, what happens is basically that when the raycast hits something, I find the collider, and then I find out what the rigid body is of whatever it is hitting, and then I just use this box to something like set the linear velocity and in the direction of, in a sense, the way that the laser is shooting forward. And I get that from this value here, where I calculated that earlier. So that's sort of like how this stuff over here works, and how you can somehow create this somehow cheap, you can say, something like physics gun. And then there's a bit more stuff here. Let's see if we can. Let's see here. Where? And good enough. So this here basically, for lack of a better word, if I press the mouse button right, is true, then it shoots the laser, and if I don't, then it doesn't shoot the laser, or in a sense I scale the laser to something like 000, like we did with the coins in the last tutorial, and the laser disappears, and then I get the length of you can say the raycast and multiply that to somehow, you know, make the laser fit. This is a bit more difficult to explain, and it isn't really that necessary, because what basically I do here is a slightly advanced way of just drawing the laser as it were in 3D. You can see that the laser is actually just a cylinder that I have built in Blender that's 1 meter long. And if I don't want it to be visible, or I'm not pressing the right mouse button, I just scale it to 000, so it disappears visibly, or it just turns into 1 point, you could say. And if I hit something, this is 1 meter. Let's suppose that you can see here that I have the length of, you can say, I have the distance to the point. So for instance, this is like 1 meter, right? So suppose that there's like 3 meters to the wall. If I scale it in this direction to 3, then it's gonna hit the wall. Does that make sense? So it's basically constantly 1 meter, and then it takes the distance to the wall and multiplies it by it. Suppose that there is a 1/2 meter to the wall, then I take the length of this and multiply it by 1/2 and scale it to 1/2 of this in a sense this direction also of the blue arrow. So in a sense what happens is that let's see if we have the laser rod here, and if you can see here, I don't know if it's that easy to see, but you can see that I can scale it on this value here to like give it a length. I don't know if you can, it's a bit easier to see here, that you can see that I can scale the length of just in this one direction, so that if I have the distance to the point that I'm trying to hit, and I can get that from the raycast, where we talked about the raycast has the distance to what you're hitting. Then if it's 1 meter, I just have to multiply it. Let's see here, by in a sense the distance. Let's see here. So I set the length. No, let's see here. This is the raycast length, so I set it to basically the distance, and basically just sort of like scale it that way. So that's a bit difficult, but I don't want to explain it too much because it's quite simple, and if you think about this, you can build it. So if I press the right mouse button, and if you need to find the mouse button, you just search for mouse and then scroll down until you find input, and then you can like get mouse button, as one of them called. There's get mouse button button down, and get mouse button up. So get mouse button is just non-stop. Is the button being pressed or not? Get mouse button down is the second you press down, it will be true. And get mouse button up is the second you release or let go of the mouse button, it will send true. But get mouse button will check non-stop. Are you pressing the mouse button or not? And that's the one you want. And when you get it, notice that it has the white arrows here. And if you don't want to connect those, you can just right click and click convert to pure node, and say that you want to check right mouse button, and then you have this here that you can connect to an if statement, and in a sense then if the mouse button is true, then you draw the laser and you scale it until the distance that the raycast you got from the raycast collision. And if not, you just sort of like see here that you just scale, you set the scale of the local scale of the raycast laser to like 0, 0, 0, and then it disappears. So it's actually a rather simple script for something like creating both a laser and something like adding linear velocity in the direction of the blue arrow to whatever I'm hitting. And that's why it looks like this. You can see that it somehow pushes things away, and that sort of, for instance, you can just do like that. And then here, let's see, here for instance, and it sort of like just adds a velocity to this and something like in the direction away, and you can sort of like push it away. And the bullets also have that effect, so you can somehow, you both have something like a really cool laser, and then these sort of like you can say bullets to somehow add to that, where you can something like have something like an Apache with a laser, with a nasty laser targeting system connected, so you can somehow shoot and something like target things. So it's something like a rather cool Apache helicopter here, as it were, flying around, and that's all like the idea for the tutorial. Notice that you can also these cubes here that I could add, so that when you hit them with the laser, that they you can see that the laser sort of like pushes them back, and if you hit them with enough bullets, they sort of like despawn, as they should technically explode or something, or change color or something like. But that's something like how this sort of like tutorial works right now. And if you follow it from the start, you should basically be able to like build something like this and have a good idea of like how Visual Script works, and so like how we can make stuff in FLAX Engine also. Thank you. Bye.